The importance of fire safety in all buildings can never be understated. Fire endangers life, destroys buildings, and cripples businesses. It is essential that buildings be protected against the onset of fire. Such protection and the use of fire-safe materials makes them safer places to visit, work, learn, and recover in. In areas that are occupied by many people for long periods during the day, it is particularly important to create a pleasant indoor environment. Suspended ceilings that have appropriate sound absorption and light reflection properties can make a substantial contribution to the creation of that environment. Also, suspended ceilings often conceal and integrate various types of services and allow easy access for maintenance. A suspended ceiling should also contribute to fire safety, and in order to make maximum contribution, it should remain stable at temperatures normally experienced in fires. The current UK building regulations only call for ceilings and wall linings to be Class O for most applications. However, is the basic Class O performance enough to really prove fire safety? Three popular types of suspended ceiling materials include gypsum tiles and resin-bonded mineral wool tiles in the form of stone wool and glass wool. It is often felt that these materials have similar performance in many respects. However, some require holes or slots to give a perceived high enough level of sound absorption performance. This perforation adaptation can have a detrimental effect in other performance areas, e.g. fire protection and/or sound insulation. Other important suspended ceiling performance design criteria include moisture and humidity resistance, which is an indicator of ease of use and longevity, sound absorption, light reflection, and fire performance. There are many aspects of fire performance with few comparative tests being made. However, there are differences, huge differences. A simple mock-up ceiling is made to compare the fire-resistant qualities of three products. Above is placed a piece of chipboard with cables attached to simulate a soffit with surfaces. All three materials, stone wool, glass wool and gypsum, meet the current local fire performance requirement. Each of the ceiling tiles are exposed to a burning flame with temperatures approaching 1000 degrees centigrade. Due to its perforations, the gypsum tile seen on the left has allowed the flames to pass through it, attacking the surfaces above. The glass wool tile on the right is the first to lose its structural stability and melts, allowing the flames to attack the surfaces, destroying them. Due to its ability to resist flames and heat, you can place your hand on the back of the stone wool tile without fear of burning. The heat and flames have passed through the glass wool and gypsum tiles, destroying the surfaces above. The stone wool tile remains intact. Today, suspended ceilings are tested in accordance with the ISO 834 curve that supposedly replicates the temperature experienced in an average fire. A fire test based on this ISO curve can often be understated, as it is based on average temperatures and not on actual temperatures, which can be 200 degrees centigrade hotter, leading to potentially totally different results and outcomes. According to the ISO 834 curve, the temperature after 10 minutes should be approximately 650 degrees centigrade. Lunds Technical University in Sweden, a leading institution within fire research since the 80s, has carried out much research, and based on this research has made new calculations of the progress of natural fires, based on today's conditions in offices, hospitals and schools, with some surprising revelations. In some cases, testing to the ISO curve would not be enough. One reason for this is that the ISO curve is 70 years old and was implemented to describe the time temperature in real fires in buildings, many of which at that time were constructed of stone materials with different internal finishes and furnishings compared with today. The fire curve used in the following test is based on the calculated time temperature curve in a normally furnished 15 square metres cellular office, with a window area equal to 15% of the floor area. Walls are 50% plaster and 50% gypsum. In other words, a very common cellular office. In larger rooms or rooms with a greater window area, the temperature may rise even faster. The Lund result was a curve where the temperature after 10 minutes is 200 degrees hotter than the ISO 834 curve that is traditionally used all over the world. In order to determine if different suspended ceiling tiles could still resist a fire at these new temperature levels, a full-scale fire test was undertaken, exposing the same materials to fire in accordance with the new fire curve from Lund's Technical University. One section of a suspended ceiling is installed in a mock-up. This section is then placed in a furnace, which simulates the growth and development of a real fire. Each material, glass wool, gypsum and stone wool, are tested individually. The increasing temperature curve within the furnace is controlled to match that of a real fire, as outlined by the research made at Lund's Technical University. Glass was installed above the construction, in order that developments during the test could be visually monitored. The first material to be tested is glass wool. The initial smoke given off is the binder being burnt off. After 2 minutes, the smoke levels increase. After 5 minutes, the temperature has reached 770 degrees centigrade, at which point the glass wool tiles become dimensionally unstable, collapsing at 7 minutes. The glass wool test was stopped. The next material to be tested was a gypsum tile. The first reaction again is smoke development from the binders used. This is coupled with steam rising from water evaporating from the tile and condenses on the glass viewing panel above as water droplets. 2 minutes have elapsed and a temperature of 650 degrees centigrade reached. Like the glass wool before it, the gypsum tile loses its dimensional stability and at 7 minutes collapses. The flames have total access into the void above. The collapse is clearly demonstrated from below. The last material to be tested is stone wool. Like the two previous materials, glass wool and gypsum, the stone wool gives off a small amount of smoke as the temperature rises and the binders burn off. At the 7 minutes point in the test, where both the glass wool and the gypsum tiles failed, the stone wool tiles show no sign of losing stability. The test continues to a point where the temperature within the oven reaches 1000 degrees centigrade and the elapsed time now stands at 20 minutes with no detrimental degradation in the stability of the stone wall tiles. The test is stopped. The stone wall tiles have remained stable and in situ, assisting in protecting the void and surfaces above. A very clear and visual testament to the added fire protection offered when using stone wall suspended ceiling tiles. This comparative test has proven the superior ability of stone wool to resist fire. We can see that the stone wool tiles have remained in place with the only visible change after 20 minutes exposure to fire being the change in colour of the grid system. To summarise the three tests, they clearly show that glass wool melts at approximately 600 degrees centigrade and, losing its structural stability, it collapses. Likewise, gypsum tiles, when exposed to fire, lose their structural stability when the water crystals within evaporate and also collapse. Stone wool, on the other hand, being made primarily from stone, maintained its structural stability, even when subjected to much higher temperatures and over a greater length of time. Suspended ceiling tiles made from stone wool provide an added margin of safety in the event of a fire. It is the specifier's responsibility to ensure that the safety of a building's occupants is also considered when specifying materials. Used in hospitals, offices and schools, the added safety margin offered by stone wool in the event of a fire can save lives. In addition, protecting essential services and the cost of replacing them should also be a major consideration for the specifier. When next specifying your suspended ceiling, insist on stone wool tiles for everyone's safety.